One of the simulators in the Harmony modeling suite is the Harmony Tactical Freight Simulator. This freight simulator is designed to help people like Jos with evaluating city logistic problems. The key design principles of this simulator are first of all that it is an empirical model based on a lot of observed data. Also, the model is agent and shipment based, making it a very behavioral model. Finally, we designed the model in a modular structure, a layered structure, separating the more strategic long-term decision making from the daily tactical decision making. The strategic part covers decisions such as producer and supplier choice and shipment size and vehicle type choice, while on a daily basis we simulate decisions like tour formation and time of delivery choice. Finally, we also developed auxiliary modules to calculate all kinds of network performances and emissions. To start with the population of freight agents, a very dimension in developing such models. First of all, we take logistic node as an important starting point. These logistic nodes, they are distribution centers located in the study area and also the depots of all the partial carriers that are in the study area. You see them here on the figure. Also in purple, we indicated the multimodal transshipment terminals that are also important logistic nodes in the simulations. For the producers and consumers, all the firms in the study area, we don't have data, but we create a synthetic populations of firm agents based on a firm synthesizer that we developed in this project. Here you see the firm population indicated in the city center of Rotterdam. To go in more detail, in one of the modules in the simulator is the shipment module. The objective of the module is to simulate a full set of all the shipments that are transported to, from, and within the study area. We do this by applying a top-down approach. The first step is to allocate the total freight commodity demand that is expected for the region to the different distribution channels. Is it direct transport or does it take place via distribution centers or transshipment terminals? Also, the model simulates the vehicle and shipment size choice, two choices that are linked together based on the economic order quantity theory. We apply a discrete choice model for this. And finally, the shipments are allocated to producers and consumers in the study area using probability functions. The result of this is a snapshot, or not a snapshot, is a total overview of the freight demand in the study area by individual shipments. The next step is then how the delivery or the pickup of all these shipments take place within the study area. We developed an approach for scheduling for this, which uses first of all a discrete choice model for tour formation, and secondly Monte Carlo simulation to determine the expected delivery time of all the shipments. The model we developed is based on discrete choice theory and is an incremental choice model that predicts the probability that different shipments are to be combined in a round tour. The result of this part in the simulation are tour schedules on a daily basis that take place within the study area. Now, for the total overview of the module, I will not discuss all the modules in detail, but this technical architecture shows the different modules. As you can see, for the conventional freight demand, we have a dedicated flow predicting all the shipments and the round tours for this, but we also distinguish other urban freight segments, like the delivery of parcels. Since the demand prediction and also the scheduling of the delivery tours for parcels is slightly different, we developed separate modules for this. And finally, to have the total demand of light commercial vehicles complete, we also simulate service trips. We also developed some auxiliary modules that are needed to also derive the necessary key performance indicators. So the network module predicts the trajectories of each individual vehicle and also calculates its emissions to be able to make evaluations of the emissions of the different scenarios. Now, to summarize and give a very quick overview of the Harmony Tactical Freight Simulator, I'd like to show you 6 figures. So first of all, we have the firm population in a study area. From this firm population, we can derive the total demand for freight transportation, visualized here. We also simulate which part of the freight goes through intermediate logistic nodes, the distribution centers. We also simulate the formation of round tours, so how will actually the delivery and collection of all these shipments take place. And all the vehicles, we determine all the route paths for the vehicles and where their emissions will take place, which can be used to derive necessary key performance indicators. And of course, all the detailed results, they can be summarized in the key performance indicators that are needed in the different policy studies.